Okay, so this is going to talk about the free response practice number 15, okay? All right, so you were given these table of values and the function right here. And then you're going to ask the question. On A, it says that two of the zeros are specifically listed in the table. What are those two zeros? Then what is the multiplicity of each zero? And you basically got to give a response to both questions. All right, so if we were to take a look at x is equal to 1 and 2, says are two zeros listed in the table because each zero has a y coordinate of 0, which makes it an x-intercept. So that's what we're doing. We're identifying the fact that the zeros have a 0 for the y value, which makes this the 0 of the function. So we've got -1 and 2 as the zeros. All right, now the multiplicity of each is going to be 1. Sorry, I guess my computer is a little laggy. All right, and that's simply because if we were to take a look at the original function, this is a third degree. So that means there are 3 zeros. So this would be 1, this would be another 1. Well, that can't have a multiplicity of more than 1 simply for that reason. And so here is an adequate response. The multiplicity of each 0 is 1 because the signs change on both sides of the 0, which means that the multiplicity is 1 or 3. Since g of x is a third degree polynomial, which means there are a total of 3 zeros, and since the table gives 2 of them, their multiplicities must be 1. Okay. All right, so now let's take a look at number 2. So we were supposed to determine the values of A and C and then show your work or give an explanation or your reasoning. All right, so here's the reasoning for the first one to identify, which is the value of C represents the y-intercept, which is indicated in the table as 0, -4. All right, so if I take a look at that, I've got 0, -4. Therefore, C is -4. All right, now we're asked to find A though. And so when you find A, there's a couple of different techniques that you could use to find A. So I'm going to go through a couple of those with you. If I can get my computer to stop lagging here. All right. So one way is to actually evaluate the function at a given point. The cool thing about this is that you're given a lot of points. You're given an entire table worth of points to choose from. The only thing you wouldn't want to choose is 0, -4, because that's not going to help you really get to where you need to go. So right here in this first example, it says I'm choosing the point -1, 0. And if I zoom in a little bit, you can actually see the algebra that I'm doing right there with that function, okay? So you can see that I am plugging in the point and then evaluating it and finding that A is -3. The other way is to perform synthetic division. And I'm using -1. It's the 0 of the function. I could have used another one. And you know what the remainder is. The remainder is going to be the y value. So you could, again, pick any point. But I, again, chose the point -1, 0. So I just put an A in place of that first term because that's what it is that we're solving for. And then you can see how I'm working that synthetic division. And then I found that A is -3. All right. And so now we are looking at C. Says between which two x values in the table does the other 0 of that function lie? All right, so well, a 0 is going to occur when the y values change signs, since the graph must cross the x-axis, right? So you're changing signs. On the table, the y values change signs between 0 and 1. So if we were to take a look at that, you can see that the y values change from negative to positive in between the x values of 0 and 1. Okay. All right. And then the idea was, all right, well, then why don't you go ahead and find the third 0? So you know your answer should be in between 0 and 1. So what you're going to do is use synthetic division. Starting off with one of the zeros, you could have either used -1 or 2. And then you get down here, and then you can divide again, or you can factor. So if you wanted to factor that quadratic equation, you can. Since you already know the other 0, then to me, it just makes it a little bit more efficient to either synthetically divide or know that that's my other factor and try to work that. Personally, I think it's easier to use synthetic division. And so I go ahead and use synthetic division. I get -3x plus 2. Because it is a 0, I know that my remainder is 0, and I'm also looking to find the 0 of the function. So that's why I'm setting it equal to 0, and I find that the other x value is 2/3.